All right, in part C, we have 8x cosine squared x dx. We have an even power of x squared, which is good. We can go back and check our guidelines for integrals involving the powers of sine and cosine. But even though cosine here is coming with an even power, we still have that polynomial x attached to that, tagged along with the trig function. I don't think that these two items would be applicable for taking care of the integral provided to us in the question statement. So in fact, this is a good application of the integration by parts. Okay, so I have liate, right? I have, let me just write that down here. Right, you get the acronyms that I used in the previous section. So we have trig and we have algebraic 8x, which is a polynomial. So I'm going to call the algebraic part to be u, and then continue from there by applying the integration by parts. Okay, so I'm going to call u to be 8x, but this time we have dv. So dv equals cosine squared x dx, and that's where we need the guidelines, right? Because at the end of the day, v is equal to cosine squared x dx. So I need to know what the antiderivative of cosine squared x dx is. Going back to the guidelines, so item number 3, I think there's a typo here, right? There's a typo here. When the powers of sine and cosine are both are even and non-negative for both sine and cosine, we use the power reducing formula. So I want to remind you what power reducing formulas are. So let's just quickly go over that. Here we go. I have some other formulas, but specifically I'm interested in power reducing formulas here. Okay, and I'm gonna swap cosine squared x to 1 plus cosine 2x over 2. All right, so I'm going to go back here and rewrite that integral as like 1 plus cosine 2x over 2 dx. And I can split this integral into two parts, 1/2 dx plus cosine, in fact, 1/2 cosine 2x. Let me just write that down so that I have two simple integrals to take care of. One spits out 1/2 x, and the other one spits out 1/4 sine 2x. And you can pause the video at this moment and you can go over this with your own pace. Please do it. So now this is v. So this was the step that was needed for me to apply the integrating by parts to the given integral in part C. Here we go. So now I'm applying it, u times v. So 8x times 1/2 x plus sine 2x divided by 4 minus v times du. Now what was du, by the way? Du equals 8 times dx. I forgot to put that side step over there. So v times du is going to be 8 times 1/2 x plus 1/4 sine 2x dx. All right, so I need to take care of this integral right now. Okay, so 8x 1/2 x sine 2x over 4 minus 8. So the integral of x is x squared over 2, so this should be x squared over 4. And sine 2x has the integral negative 1/2 cosine x, so that's negative 1/8 cosine 2x. Again, there's a lot of integrations going on here. Please pause the video and verify each step carefully. There's a hidden u substitution when I integrated that, but at this level I skipped that because we covered them all in earlier sections. If you're still rusty though, just go with your own pace, please. Pause the video and digest every single step. Okay. All right, let's continue with adding an integrating constant. And I'm going to write the final integral after I expand this out. So that would be the final answer of this problem. So 8x times 1/2 x, and that is 4x squared. 8x times sine 2x over 4 is 2x sine 2x minus 8x squared over 4. That is minus 2x squared plus cosine 2x, right? Cosine 2x plus the integrating constant. All right, I think that's the end of it. You can simplify certain terms here, like for example, 4x squared and 2x squared are like terms. You could just like simplify that as like 2x squared in the next step. If you want to write one line down there, I would just write the simplified version as like 2x squared plus all trig related terms. Okay. Woohoo! So I think this is the end of the video. We just covered all sub questions here. All were like different integrations, so we applied different strategies. So this is the end of the video. Thanks for watching. I'll see you in another video. Bye.